So in this video, we will do exactly the opposite of what we did whenever we expanded logarithms. So instead of ending up with multiple logarithms in our answer, we will be writing several logarithms as a single logarithm. So we will use the same three properties that we focused on whenever we were dealing with expanding logarithms. So we will go ahead and take our coefficients of 2 and 3, and we can bring those in as exponents. So we would have natural log of x squared plus natural log of y cubed. Now we are adding two logarithms. So whenever we add two logarithms, we have log base a of m plus log base a of n. We can write that as log base a of mn. Natural log of the product of x squared and y cubed. Now let's look at another example. Here we are subtracting two logarithms that have the same base. So we can rewrite that as a single logarithm. And in so doing, we are going to divide the arguments. So we're taking log base 4 of 6x squared plus x minus 1 over 4x squared minus 1. Now let's see if we can factor that numerator and factor that denominator. So we have log base 4 of 6x squared plus x minus 1. Let's try a 2x and 3x. Plus minus. Does that work? 6x squared, and then we'd have minus 2x plus 3x would be our plus x minus 1. Then the denominator is a difference of squares. So we have 2x plus 1, 2x minus 1. So 2x plus 1's cancel. So this is equal to log base 4 of 3x minus 1 over 2x minus 1. We can put parentheses around this argument just because it's rather large, but no, it's not absolutely necessary to do that. Okay, let's look at this one. We can bring in 3 as an exponent, 4 as an exponent, and we end up initially with log. Now you'll notice the base isn't written, and that's because this is base 10. Now the quick way to do this is we're going to write one logarithm now that we have no coefficients left. And the logarithms that are being subtracted, we're going to put their arguments in the denominator. So x cubed goes in the denominator, x cubed goes in the numerator, and then the denominator will have x plus 2 to the 4th, x plus 1. Now, just to be clear, what are we taking the log of? We're taking the log of this whole fraction. This is the input of this entire logarithm. This is not log times this expression. It is log of this expression. Just like f would be f of something, this is log of this whole quantity.